me we're going to get here?
Might as well just start.
Yeah. Okay, I was kind of hoping that this would be sort of an interactive thing because otherwise it's probably not going to be that long. But, wait, first off, the PBMS daemon. I've decided to start calling it a daemon as opposed to a storage engine because it gets a little confusing when you talk to people about using this with their InnoDB storage engine, and they'll say, well, kind of why do I want two type thing. And although internally it's built as a storage engine, to anybody using it, it's really a daemon. So that, hence name change. So, who am I? I'm Barry Leslie, and I work for Prime-Based Technology, which is actually a company that's based out of Hamburg, Germany. And one of my main projects right now is working on the open source project, the PBMS daemon, and PBMS stands for the Prime-Based Media Streaming daemon. And what it's intended to do is to handle blob data for the MySQL or Drizzle server. And yeah, I live in Victoria, BC. I telecommute daily to Hamburg. And at the bottom is my email address. So, what is the problem that we're trying to deal with? Basically, MySQL does not handle blob data very well. The problem really isn't with storage engines. You can store blob data, no problem. That's not the problem. It's getting the data to and from the storage engine that's the problem. Because in MySQL, the blob data is basically handled the same way as any other data streamed through, and it tends to, well, basically gum things up. And so, particularly, it doesn't work very well with MySQL dump, because if you try to do a MySQL dump on blob data, it'll bin hexes your 20 meg blobs and tries to dump them all to one file for you. So that's not particularly useful. And the same sort of thing happens if you're trying to do replication in your bin logs, that you get all the blob data in the bin log, which doesn't really work so well. So the solution that we've taken is that you basically stream the blob data outside of the regular channel on client-server channel on the MySQL server, and so that the blobs themselves are passed outside the server around to the PBMS daemon, and then in place of the blob data you insert references to it, which the PBMS daemon returns when you insert the actual blob data. This is pretty much like what everybody in the MySQL community tells you to do. If you ask them about storing blobs in your database, they tell you you don't store blobs in the database. You store references to your blobs, and you put your blobs off on your file server somewhere. And exactly how you get the blobs there and keep track of them and everything else is kind of left as an exercise to the student to deal with. But it's not considered a database problem. So this really provides a generic solution for everybody, which is built into the server, and so that the referential integrity with your blobs is also maintained, because it keeps a reference count, and so that when no records are referring to the blobs anymore, the blob will automatically be deleted from your database. And as of the last couple of versions, there's now a separate backup system for the blob data, so that you don't have to rely on MySQL dump to do it. Although MySQL dump will work with the blob repository also. And in the case if you're storing your blob data completely remotely on S3, which is also supported, then actually MySQL dump works fine, because you're no longer backing up the blob data, you're just backing up the references. And the PBMS daemon actually handles the backup on S3 for you, so it will actually back up the data there. Okay, so that's in my little thing there. So if anybody reads my blog at all, you've already seen this probably. So this is how the insert works for the inserting data if you're actually storing the data on S3 server. That the client side we provide an API or library which the client uses. There's also a HTTP module for it also, so you can use it directly in HTTP. And the preferred way to do it is that you kind of send the blob to the PBMS engine. And if you're storing the blob data on S3 storage, what you're actually sending is kind of the metadata for the blob to the PBMS engine, which is stored in the repository. And the PBMS engine, I'm calling it engine again, sorry. It sends a signature back to you, which will allow you to upload the blob to the S3 storage, so that the actual blob transfer is done from client to S3, and it never actually goes through the server itself. Just the references and metadata is actually stored in the repository, so that the retrieval of data is pretty much the same. You send a message to the PBMS engine, which then sends basically a redirect. It redirects you to the S3 server, and then it's passed up into your client. All this redirect and everything else is handled within the library there, and so the client doesn't need to know anything about it. The only thing the client does need to know about is that when it selects blob data back from the database, that it's actually getting a blob reference and not the actual blob data itself. So it needs to then take this reference and pass it off to a call to the PBMS engine to actually get the blob data itself. So that's kind of how things work in general. Also, you don't need to store it in S3. The original storage was the native storage on the hard drive itself, in which case then the data is just sent to the PBMS engine for it to store on the locally. Although in that case, the data still is not being passed through the MySQL Drizzle server at all. It's being transferred outside of it. So then what I'd like to do is to do a little demo here. Find where I am.
Most people don't know that they don't download the geo IP database and stuff. If you're using the geo, they're that long. Yeah, that's the point.
Okay, so here we have the MySQL server here, and you can see that there's actually a PBMS database here. This is actually where the PBMS stores its own information, so it's not really a database that you create. It's done pretty much the same way that PBXT does. It has its own information, like all its logs for its transactions and everything else is stored in the PBXT database. And PBMS provides some of its own tables. This one that we see right here is the backup table. It keeps track of backups automatically, and so that if let's see if we can scroll this across a bit. So we got columns in here. I've got an ID, which is just a generated ID number, and it gives a database name that's being backed up. Database ID is a database ID which is generated by PBMS. That it refers to things by IDs because database names can be reused, and so it needs to know kind of an ID so it knows really what database it is. The ID is quite simply just a timestamp when the database was actually first created and that. So then it keeps track of when the backup was started and when it completed. There's a field there letting you know if it's actually still currently running, and there's another field called isDump for whether it's a backup that's been generated by MySQL dump, and then there's a location field, a cloud reference, and a cloud backup number. So the got two ways of doing backups. You can do a standard MySQL dump, and the way that works is that PBMS provides a dump table in the in your database. It's a virtual table, and basically it contains one column. Each column is a blob, so it has really no user friendly data in there at all. It's just purely used for dumping, and you're best not to make any assumptions about what that blob is, because there's assorted things stored in there when it gets dumped, and then when it gets brought back in, it takes these blobs in, interprets them, and recreates your repository from that. And if you're using S3 storage, then this is just simply the metadata, and these blobs will be a reasonable size, and so they're not a major problem to actually handle with a MySQL dump. If you're actually storing the data in the repository itself, then these blobs will contain the actual blob data, and so you're kind of back to the same situation where it's you've kind of blown out your log as you're trying to bin hex these things. The other type of backup you can do a repository level backup, in which way you start one of those, you just insert a record into this backups database, and what you're telling it is kind of what database you want backed up and where you want it backed up to. And if you've got a if it's being stored in S3, then you can give a cloud reference to store it, use the storage in potentially a cloud backup number, which I'll talk about later. And so what happens is when you insert one of these records, it starts an asynchronous backup of the repository, and it takes the repository and copies it off to the location which you specify there. And what that is a literal copy of your repository, and the recovery from that is simply you generate your database, you restore all your normal tables, and you simply drag and drop this back into your database, and it's recovered. So that kind of recovery is extremely straightforward. And there's a little trick to that when you're dealing with S3 storage, because it then needs to know to recover the blobs from S3. And so what it does the first time you try to access that after dragging it back in, it realizes that this is a recovery, and it goes off to S3 and kind of transfers the blobs back. So we'll go back to PBMS database here. In the PBMS cloud table, this is where you keep your repository information for S3. And we've got an ID number here, and the server, the bucket name, and public and private key, which is all that you need to actually connect to your S3 server. All the blobs that are stored in the repository for S3 are referenced via this repository ID here, so that when you can actually, if for some reason that partway through you decide, no, actually I want to store my blobs now on this repository, you can just go in here and change it. And maybe I should make a mention about there's a variables table here in the database, and that tells you the PBMS engine sort of how to store the data. In this case it's cloud, and the repository number, which it's supposed to use for the S3 storage. So this is how the repository, or the PBMS, even knows where to store the blob data and how to store it. We'll go back to our cloud here. So okay, so that every blob that's stored has this reference ID stored with it. So that way that when it actually goes to get the data, select the data back, it needs to go to this table and find out what S3 storage the blob data is actually stored on, and then it sends that information back up to the client. This allows some flexibility in that it allows you to actually take your blob data and move them around in S3 storage. if you've got a better server becomes available, or you want to change the bucket, for instance, which is quite reasonable to do because you can actually associate buckets with different regions. So you can have a European region and a North American region, and so you decide that, okay, all these blobs are being accessed by people in Europe. You can go and create a new bucket, transfer your blobs over there, go in here, change this information in here, and then everything from that point will be referring to it from that bucket, and then you can delete the old ones, and so you don't need to actually touch anything in your database. You can sort of move things around that way. Alternatively, that's also another way that you could actually use to back up your blobs. Okay. So, yeah. Okay. Also, going back to backup, that the variables table, there's a flag here that you set if you are doing a recovering the data from a dump, MySQL dump. That this flag is used to inform the daemon that the data is being recovered, and that way it knows that when the data is being inserted into your tables, the regular engine, that it isn't supposed to be referenced. There's a reference to it already, so it doesn't do any reference counting while this flag is set to true. And so that that way that you can recover the data and it doesn't have to update anything in the repository. Okay. So there's a few kind of internal tables here which are kind of sort of give an internal view of what the data, how things are dealt with in the repository. This is a repository table itself, and blobs can also, you can have an alias associated with a blob if you want to get the blob by alias as opposed to the URL generated. That allows you to sort of specify a name that you want to use for the blob, which maybe makes more sense than the kind of cryptic string that will be generated for you. So you can actually access these. Mostly the stuff in here is just kind of an internal view of what's going on in the repository. It also keeps track of access times and various information about the blob. The reference is actually, like, this is actually the URL that you would use to access blobs from the database, which includes assorted information. The first one up here being this section of it is actually just simply the database ID, and it's just a string of various information about it. But most of these tables, they're just kind of, if you want to look under the covers type thing, what's going on. Yeah, so let me see. We can. Yeah, I'm not sure if anybody has any specific questions at this point, or we can run a couple of PHP scripts here to find where we are, which will actually do a few things. Like in this case, this is a script which will do the MySQL dump on the data. It's just one of the ones that I use for testing this. Yeah, right now it's sort of generating blob data to be used. Yeah, so this is kind of some sporadic errors which will come up when you're dealing with S3. It's all handled internally, just for debug purposes. I'm dumping some of this stuff out. That when you're dealing with S3 storage, that you have to assume that not all your transactions are going to work, and you have to restart them, and that's just the way that S3 works. So that we were to go back here to our backups table. So we should have another dump here. And actually, this is already completed. So that one would have been this one there. To just then add a record there. Also, when you're dealing with S3 storage, because the data gets backed up in S3, you need this information that's being kept in their backup table is interesting, because if you want to get rid of your old backups, then you need to actually go into S3 and get the data and delete it there. This is, sorry, I've intentionally kind of done it that way because, I mean, I could in theory had set it up so that if you deleted the record from there, it would go and clean up your data. From a programming point of view, that there's no big deal about doing that. The problem with doing something like that is it may not be expected behavior from somebody who just goes and deletes something from their backup table. They may not expect that to actually be deleting their backup also. So that for the people who that might have been nice, that there'll be lots of other people who will scream and holler about it. So this is actually looking at the S3 storage on Amazon, and these numbers here correspond to the database IDs, and here this first number here being a 1, that would indicate that it was a backup. That's for the backup reference number that you saw in one of the backup tables, and the reference number of 0 is your live data, and anything other than 0 indicates it's a backup. And then these are kind of your BLOBs, which have been their IDs have been generated and been stored here. But so if we go back up, and not sure whether actually this is probably the backup from which I just made. Being that the backup IDs are actually timestamps, you can kind of tell which they are, sort of. Anyways, you could match them up with the database IDs from the backup table, and you could find out where it actually is. So, by the way, this is kind of the S3 plugin for Firefox, which, if you ever deal with anything with S3, that's a really valuable tool to have. Okay. Let's see. So, anyways, this is sort of what this script actually did. It ran MySQL dump, and it did a dump on the this database, which included the PBMS dump table, and then you insert the data back into it. When it gets inserted back into the PBMS dump table, then it sees that as a restore operation, and it restores your BLOB data again. That's more or less what I've got to say. That have any questions or ideas or general comments?
Does it support writing to both local disk and S3?
Pardon?
To local disk and S3?
Not currently. That it's kind of an either or. That why would you want something in particular?
Well, we try and store everything locally. Well, one for backup purposes, but two, in case there's some sort of problem with S3 or AWS, we can quickly flip to our local system, flip our URLs to local. But I guess we'd have to backup storage just with the client.
Yeah, I guess if you're concerned about storage, I mean, in theory, there's no reason why you couldn't actually do it both ways, and that could be potentially, just another type of, currently like there's local storage and cloud storage is supported, but it's left open-ended so that you could have, and it would just be that the actual blob data would be replicated someplace else, and in theory that could certainly work. And, so anything else? And, some of the things that I would like to do with this is to actually set up a take it and set it up as a standalone sort of blob repository, so that you could actually have basically it'd be kind of like another form of storage, and that stuff would be remote, and so the actual repository would reside someplace else on a completely different computer, and everything would be just kind of sent there via proxy, and nothing would actually be stored in your local database. One of the appealing things about that would be that it would probably be a solution that would work with a clustered server, because then all your blob data would be remote, and it would work with multiple servers. We'd just be referencing it from one location.
Since then, they have blob-based mobile FS cluster to keep the blobs under.
Yeah, something like that also. And so that's kind of about as much as I think I had to say, unless other people have some comments to add or more questions.
Thank you.
Yep. By the way, one of the things that I didn't mention is that this can require support from the actual storage engine, which can be built in fairly easily in the current versions. I built it in this example was using an ODB. PBXT supports it, and just recently I was playing around with just building it into Tokyo-Tech engine, and so that it can be added fairly easily, and then Drizzle, I hope that it'll actually be supported by the server itself, so it will be dealt with directly at the server level. What it does really is it works as a filter for data going in and out of the server and sort of catching blob references. And if you're actually inserting a blob data, you can still do an insert directly with a normal insert statement, and what it'll do is it'll take the blob data out of the insert and store it locally, and then replace the blob data with a reference, which will then be handed to the normal storage engine. So a normal insert still works with blob data. It's just that depending on how many blobs you're inserting like that, you're back to the problem that you have to now pass the blob through your client and server interface, which when the blobs start getting large, then you're using up a lot of memory to do that. So the other approach where it goes around it, it also is a streaming interface, and so that you don't need to buffer anything along the way. You can stream data directly from one end to the other end without actually having to load it into a buffer and then sending the buffer off. so it's fairly efficient that way.
Is this an alternative to mobile FS?
I'm not that familiar with mobile FFs, although I would think probably not, because it's actually integrated in with the regular engines, and so that it actually kind of it has this filter ability. It also, I said, I'm not sure how many people actually knew about this to begin with, but the PBMS engine provides an HTTP server, which is how you communicate it with it directly without going through MySQL or Drizzle, and so that you stream the data directly to it and back from it. That's all handled inside the client library, although you can also stream, you can take the regular curl app and stream data in and out of it using that if you want to. It also works. Yep. Thanks for coming.